Good afternoon, everyone. I'm Nishay. I'd like to welcome you all for our presentation on our topic called heart failure prediction and heartbeat anomaly detection. Now I'm going to continue with my introduction part. Heart failure is a common event that is caused by cardiovascular disease. Cardiovascular diseases are the leading cause of deaths globally, taking an estimated of 17.9 million lives each year, which accounts for 31% of all deaths worldwide. Cardiologists use traditional clinical methods such as electrocardiography and blood tests to detect the heart diseases. The most recognized risk factor for heart failure are hypertension, coronary artery disease, diabetes, obesity, and smoking. Some common symptoms are shortness of breath, fatigue, reduced ability to exercise, and so on. People with cardiovascular diseases or who are at high risk of cardiovascular risk need early detection and management, wherein machine learning model can be of great help. In this project, we try to build a model to predict heart failure and also do the analysis on heart failure dataset. The patient data will be fed into our model and we will have the output of the percentage of chance that the patient are suffering from the heart failure. Now, my friend Mohan is going to explain the existing and the proposed system.
Thank you, Nischay. Hello, everyone. Now I'm going to explain about the existing system of our project. However, may the technologies improve, but still the cardiovascular diseases, or simply known as CVDs, remain the leading cause of death globally. In the existing system, the patient has to undergo many series of tests, which are done by the cardiologist manually in order to detect the heart disease. There are many tests which are done during the heart disease detection, which include physical test, chest X-ray, ECG, and so on. The tests are in turn time consuming and they are only available at the urban areas, making it difficult for the rural people to approach the hospitals and get tested. Even it is too expensive for them. Therefore, to overcome these problems from the existing system, we are proposing a system which uses machine learning and deep learning techniques for early detection of the heart diseases. The prediction will be carried out based on the old patient records who got the history of heart diseases. Input is taken from the users in the form of audio files of heartbeat sounds, which are recorded through the digital stethoscope and are predicted using a model. The input can also be blood test report attributes such as serum creatinine, serum sodium, if the patient smokes or not, ejection fraction, etc. In the proposed system, we try to reach the maximum efficiency by choosing the suitable classification algorithm for prediction. Thank you. Now Nitin will explain about the objectives of our project.
Hello everyone, I am Nitin. Now I am going to explain about the objectives of our project. Objectives are the goals which we plan to achieve by the end of our project. The main objective of our project will be building a suitable model to predict which has maximum efficiency and produce accurate results. The performance of different classifiers are studied and evaluated in order to get the most suitable model for prediction. Number of errors will be reduced which come from the manual system. Irrespective of any user old or young, risk is predicted and easy tracking of data should be incorporated. The model should be easy and cost effective, which was the major problem in the existing system. Emergency service is a critical function because early detection is very much essential for a heart disease. It can be done by giving emergency alerts to the user and consulted to a doctor. The next one is methodology. Thank you. Now Nishchay will continue the literature survey.
The title of our first paper is Regularized Helm and Inclined Entropy Measurement for Congestive Heart Failure Prediction. The authors are Abdullah Yaik, Yaqub, and Gorkan Altan. It is taken from National Defense University, Ankara, Turkey. It was published in the year July 2019. In this paper, the study concerns with automated predicting of congestive heart failure through analysis of ECG signals. A novel machine learning approach regularized Heisenberg decomposition based extreme learning machine and features models, squared, circle, and inclined and grid entropy measurement were introduced for prediction of congestive heart failure. With the help of the ML algorithm and ECG signals, it can be achieved at a good accuracy. Next paper. The next title of our paper is Automatic Feature Extraction for Phonocardiogram Heartbeat Anomaly Detection using WaveNet. The authors are Robert George Colt and Songer Ruban Veredi and Ricardo Volpi and Luigi. It was published on February 2021. This paper will focus on automatic feature extraction of raw audio of heartbeat sounds aimed at anomaly detection application in healthcare. We take have trained the model with. In this paper, they have divided it into normal heartbeat, murmur heartbeat, and extrasystole heartbeat. Then it is going to detect the anomaly and present the result. Next. The next title of our paper is Performance Evaluation of Machine Learning Based Big Data Processing Framework for Prediction of Heart Disease. The authors are Abraham Ed Dowdy, Khalil Malmi. The journal was published in LTTI Laboratory, Higher School of Technology. It was published on May 2019. In this paper, one of the major outcomes is various data mining and machine learning methods are available. In this study, the performance of four main algorithms performed on the datasets using Apache Spark, by which we conclude that the uh, random forest reaches the best performance in terms of the accuracy with 87.5 percentage. Now, my friend Nitin is going to continue the further papers. Thank you.
The title of this paper is Heart Disease Detection Using Machine Learning, Majority Voting, Ensemble Method. The authors of this paper are Rahma Atallah, Communications Engineering Department, Princess Sumaya University for Technology, Amman, Jordan. The year of publish is October 2019 and the paper is from the journal ICTCS. The major goal of this project is to provide more confidence and accuracy to doctors' diagnosis of heart disease. As in the present era, heart disease rates have dramatically increased to become the leading cause of the death among adults due to widespread unhealthy habits. In this project, UCI repository was used to retrieve the heart disease database. Using the approach of majority voting ensembler method, the accuracy of 90% is produced. The major advantage of this method is it reduces the 76 attributes of UCI repository to effective 14 attributes. Here, in the project, the prediction is done using various classifiers such as stochastic gradient, KNN, diagnostic regression, etc. And it is found that ensembler classifier come up with highest accuracy of 90%. The major conclusion about this paper is the reduction of 76 to 14 attributes made it easy for the implementation. The next paper is number 5. The title of this project is Smartphone based ischemic heart disease risk prediction using clinical data and data mining approaches. The authors are Sudhir Anekal, Chandrasekhar Upin, Amresh Badrashetty. The year of publish is 31st Jan 2020. It is from the journal International Journal of Journal of Computer Science and Engineering. The major goal of this project was to develop a mobile application to predict the ischemic heart disease or commonly known as artery disease. According to WHO report, the loss of life is 6.96% because of ischemic heart disease. Here, the approach is clinical data mining and classify the risk as low, medium or high. The methodology in the project include building risk score tree, and applying chi-square correlation and generate risk store tree and predict heart attack risk based on risk factors. The inputs taken in this project are blood pressure, cholesterol, etc. The conclusion from this project are mobile apps are playing vital roles in day-to-day life and they could help lots of people to acquire health information, advices and guidelines. Mobile application uses data mining technique where several questions were asked to predict WHO alert the person to consult a physician. Thank you. Now Mohan will continue from here.
Thank you, Nitin. The title of the next paper is Heartbeat Sound Classification Using Deep Learning. The authors are Ali Raza, Arif Mahmood, Salimullah, and team. The year of publish of this paper is 5 November 2019. It is taken from the journal National Research Foundation of Korea. The major challenges or problem defined is presently most of the deaths are caused by heart diseases. To overcome the situation, heartbeat sound analysis is a convenient way to diagnose heart disease in the heart disease. In the proposed model, the noise from the heartbeat sound signal is removed by applying a band filter and after fixes the size of the sampling rate of each sound signal. Here the model used is RNN or recurrent neural network. The input for the model is collected from the digital stethoscope. The final result of the model will be whether the patient requires further treatment or not. The major conclusions from the study is by applying deep learning model that is RNN, it has apparently increased the accuracy of the system and it is more competitive and efficient. The next paper is paper number 7. The title of this paper is Heart Rate Variability Analysis on Reference Heartbeats and Detected Heartbeats of Smartphone Seismocardiograms. The authors are Zayman Siensky, Pavet S. Kotska and team. The year of publish of this paper is August 2019. The journal is Information Technologies in Biomedicine, 7th International Conference, Poland. Here the major problem defined is HRV or heart rate variability, which is the physiological variation of the time between consecutive heartbeats. A low HRV indicates that the body is under stress from exercise or psychological events. Also, it can lead to cardiovascular diseases. Seismocardiography is a non-invasive method of recording and analyzing cardiac vibrations by measuring periodical acceleration. The input is taken from for this project is the SCG signal recorded through the smartphone. Accelerometer application is used to register SCG signals using sampling frequency of 100 Hz and sensitivity of 0.009 ms. The smartphone is placed closely on the chest wall for recording the vibrations made by the heartbeats. The recordings from the smartphone were exported to text files and analyzed offline using MATLAB software. The proposed algorithm consists of signal processing, RMS envelope calculation, and peak finding. Algorithm performance was compared to reference beat detector and defined as sensitivity SC and positive predictive value PPV. The overall performance of the detector was promising as the PPV value was over 90% accurate. The next paper is paper number 8. The title is Effective Heart Disease Prediction Using Hybrid Machine Learning Techniques. The authors are Senthil Kumar Mohan, Chandrasekhar Tirumalai and team. It was published in the journal IEEE. The year of publish of this paper is June 2019. The proposed model in this paper aims at finding significant features by applying machine learning techniques, resulting improvement in the accuracy in prediction of cardiovascular diseases. The prediction model introduced different classification techniques and it produced an enhanced performance level with accuracy level of 88.7%. Through the prediction model for heart disease with hybrid random forest with linear model or HRF-LM in short form. The dataset for training the model is chosen from the UCI dataset for heart diseases. The proposed method is used on all 13 attributes and classified based on error rate. The result clearly proves that all features selected and ML techniques used prove effective in accuracy predicting heart disease of patient compared with known existing models. The major conclusion from this paper is this approach have achieved extremely high performance in all settings, and also the random forest classifier is found to be the more accurate as compared to other models. Thank you.